clicker, and you want me to multitask here. This is not what I was designed for, but let's see how far we get. So it was designed for fast consensus in localized distributed networks. So an example of that is automated cars in a non-traffic environment. Why do we have traffic lights? Because the cars need some way to instruct each other. I need to stop, I can go, you need to stop, I can go, etc. So if you remove the traffic lights and you want all of the cars to be able to interact with each other and in that localized cluster make decisions with malicious parties potentially, you need some way for them to very quickly communicate to each other in real time and arrive at decisions. So if you can do that, all of a sudden you can imagine all of these cars moving at 100 miles an hour crossing these intersections because they know the information from the other vehicles that they're going to be interacting with. So it started off with this premise, and it led itself nicely at the time to a lot of research that was going on in this area, which is specifically surrounding consensus and the problems with it. As mentioned, you have Bitcoin, you have Ethereum, you have all of these front runners who as a design mechanism, and there's a reason they were designed that way, but as a design mechanism, they're fairly slow and cumbersome. Bitcoin, your average transaction is going to be 10 minutes. And if you want to have statistical finality, you're going to be waiting around 30 minutes, 3 blocks, give or take. Ethereum, 30 seconds per, so it's about 60 blocks for real finalization. Did I do something wrong here now? No, but I'm not on. I could have definitely messed it up. And I don't think this way, okay, it's the one. All right, there we go, thanks man. So Fantom is, and this is where there's an interesting distinction, because people often, there's block, and this is why I mentioned, Dan, that I have a little segment on this. It's actually a little bit later, but I'll just mention on it now, is because there's blockchain as a data structure, which is a block that points to another block with a hash to the previous hash. And then there's blockchain, the category. Technically, all of these cryptocurrency blockchains are part of the blockchain category. And I say that specifically because we're talking about high scalability DAGs. I saw earlier there were quite a few hands on DAGs. I'll have a little bit on it in a little section. But Bitcoin is a DAG. I mean, Bitcoin is a directed acyclic, can only go from the one section to the another section graph. So even though nowadays we have all of these DAG protocols coming out and everyone's making a scene about DAGs, Bitcoin's a DAG, Ethereum's a DAG, all of them are a DAG structure. So as far as the classification of a data structure goes, all of this stuff is DAG, but they all form part of the blockchain category, not necessarily the structure. But now I'm going on into a little bit nomenclature. So it's got this high scalability DAG, which I'll explain in a little bit. Then on a different research side, this is more from University of Sydney and the guys in Australia. There's the secondary problem to something like Ethereum, in that its original goal was this world supercomputer. It's so that you have the combined resources of all of the participants in the network. What we've seen with proof of work unfortunately is a synchronous system. So it can only allow a single set of actions to happen at any given point of time. So if I want to execute 1 + 1, instead of being able to execute that 11,000 times for all of the nodes in the network, 1 + 1 is going to be executed 11,000 times so that all of the nodes arrive at the same answer. So now instead of having a parallel processing system, I'm forced to have a single event that's processed by all of these nodes. So the other thing that was important was verified computing. Now I'll go into it a little bit later as well, but just a high level concept is this way that if I do 1 + 1 and I give you the output of 2, I can also give you a proof along with that. Now this is where zero knowledge proofs come in, that shows that the circuit's executed in that fashion so that I arrive at that state of 2. So now instead of you needing to run the processing of 1 + 1, I give you the state and I give you the output, and then you can apply that to your ledger yourself. So that's a secondary mechanism that allows for this parallel computing system. So the high-speed consensus along with the parallel computing starts giving a lot more power on unlocking the design patterns in terms that we see in DLTs. And I apologize, Fantom is a research and technology organization, so we are very research and technology focused. So this is going to be boring for some, so I'll preface that. But what it comes down to. Okay, so very quickly, like I mentioned, the high scalability consensus, which is unlocked via the DAG and the parallel consensus. We've got the VM, which is verified computing and formal verification. It's a proof of stake system. Unfortunately, some of our marketing guys asked me to put this in. 3 million bonded stake, 15% annualized returns. I don't think that stuff matters, so let's move on. Yearly returns on the stake. I'm just going to skip that as well. Okay, so I'm sorry, guys. I know it's important, but it doesn't actually affect the system in any way. Whether it's bonded stake or whether it's just voting by weight, it's the same outcome. It's just game theory mechanics, which is different to the technology itself. Quick demo. I'll try and do this as quickly as possible. We have a testnet up and running. It's anywhere between 21 and 25 nodes. We stole some of Netflix's Chaos Monkey technology. So at any given time, it tries to randomly crash nodes to create a very malicious environment so that there's disconnectivity between the clusters. There's network latency. There's all of these things. Now, this is only a 21 cluster node. So, I mean, that is tiny in comparison to blockchains. A blockchain that's truly decentralized, you'd be looking at 1,000, 7,000, 11,000 nodes. So I'll explain later why the results I'm going to show now will be a little bit slower eventually, but still, I'll go into it now. So a base part of the ecosystem is that it is a payment protocol, even though that payment protocols aren't necessarily important. I should take that back. They're very important. They're just not necessarily important now at this technology stage. So I've got my phone connected here. And I apologize, but I'm going to have to put down the mic for a bit. First things first, just to prove that this is the live connection. Let me swap that around. Hello, audience. Okay, my phone. It is showing there? Okay, cool. Thanks, man. I'll try and do this as quick as possible. So we go to the Fantom application. This is currently connected to the testnet. So I will do a quick shop. Let's grab a Google hoodie. Add to checkout. Okay, so we want to transfer funds. Scan the QR code. We need to pay 20, what's that? 22.15, 22.16, send, confirm. Me receiving this successful transaction, that's not submission, that's actually finality. To show that, let me actually just do a new version here, because I was playing around with this earlier. So shop now, let's grab this one now, add to cart, check out. 45, so, well, I'll show you on the screen just now. Let me just do this one again quick. 45.65, 45.65, send, confirm. Okay, so there we go. So that was a little bit of a lag because there's a push notification system behind it. But that, if we go to the logs quick, so this is just a single machine that I've got filtering our logs. So here was the submission of the original request, and here was the confirmation request. Now this is not like a blockchain solution in that if you look at something like Bitcoin or Ethereum, we have the longest chain rule. So what this means is that we don't actually ever have true finality. You assume after 3 blocks, the Bitcoin blockchain isn't going to be rewritten anymore, so it's safe to use. But a longer chain could come along and actually wipe that out. So if there's been a secret underground lab mining Bitcoin since day one and they have better processing power, then they could have a longer chain that they could replace the entire Bitcoin chain with today and then wipe out every single transaction that has ever happened. So there's never true finality. In BFT solutions, you do have true finality. So quickly, BFT, standard Byzantine fault tolerance. So that is where I ask everyone in this audience, do you agree that it says demo there on top? I collect the votes of everyone, and then when the majority have agreed, it says demo on top, we have finalization, because we all agreed on that. It can't change anymore because the vote occurred. That's standard BFT. Asynchronous BFT is this concept of not needing to have interaction with everyone at the same time. Okay, this is for the marketing guys again, some new partnerships, our network. This is a new ZAR-backed stablecoin in Africa that's building on top of the platform. This is a new insurance and banking system that's building on top of the platform. More details on that from the marketing people. I'm skipping along. Directed acyclic graph. Okay, so what does it allow? Parallel processing. How do we conflict resolution and time ordering? So anyone that sees this, you'll say it's a blockchain, right? Normal blockchain, block after one that looks at a hash. This is where I argue, look, this is actually a DAG, and it is of the category blockchain. So what's a DAG? A DAG looks more like this. So you have neat, ordered, one at a time, synchronous events, multiple parallel events. So how does this work? Quickly going through this. Genesis, everyone has the same Genesis block, and then any node at any given time can propose a new block. So node A that sits here proposes this block. Now in a BFT solution, it would broadcast this out to all other nodes. It would collect the votes. It would then again share the final results, and then everyone would decide on this. Asynchronous BFT is this concept that at any given point in time, I'm A, not going to know all of the participants, and B, can't at the same time interact with all of the participants. So what it does is it does bonded stake voting. So by virtue of when C here proposed a block, it referenced this block. So by referencing this block, it's giving its implicit vote to this block and saying, I'm also happy with this block. So now you have these two that have it. This block, by building on top of this one that built on top of this one, is agreeing with both this block and this block. So as gossip propagates through the network and this block gets shared faster and faster and faster, and other blocks are building on top of it, you end up having this fake vote that is about the fact that I'm bonding to a previous one by reference. So when this block is created, you don't have finality. Once it's been shared through the network to a point where more than 2n/3 of the participants are aware of the blocks, then you have something close to finality. In fact, you do. The real finality only happens another round after that, because you have this concept of known about known. So you want to not just know that 2n/3 of the network know about this block, but you want to know that they also know that it is known. It's a convoluted concept, but it works quite well in math. Okay, how many tech people do we have? Raise of hands. I just want to see how excessively technical. Okay, we have a fair amount, so I'll go into this. So an important part of this is what happens if there's a double spend year on year, and how do you resolve that? Because which one happened first? Because that's what a consensus is at the end of the day. It's an ordering mechanism. It's a way to assign when what happened without trusting logical clocks, because a clock can easily be manipulated in a decentralized or a distributed environment. So Lamport, and this is very old research, Lamport was one of the forefathers on almost all things distributed systems related. So we had this concept of a logical time. So Genesis is 1 and everything starts with 1. And if I create a new block and it references 1, then I increment the count. Now it's simply 2. So if you do that a few times, this block references 2, so it becomes 3. It references a 3, a 2, and a 4, so it becomes 5, and you just increment that amount the whole time. Now, this is the first and easiest way to order, because now you know 1 happened before 2, happened before 3, happened before 4, happened before 5. But now you still have this problem that what about the conflict that occurred in 3 and 3 here, in B3, which is the B node that produced it, and D3, which is the D node that produced it. So the next thing you extrapolate out of this is how much of the network knows about an event, because that references how long of a time it's spent in this network. So looking at this picture and assuming that this was time flow, which is not, by the way, you'd assume B3 was first. But if you look at B3, no one yet knows about B3. No one else has bonded on top of it. So B3 has not spent a lot of time in the network, versus D3 already has a 5 and a 4 Lamport bonded to it. So it has spent more time propagating through the network, which means it's also younger than the B3. So you have this concept of the amount of bond and stake you have on top of a node is its time ordering in the sequence. The very last one is if the bond is also the same, but then practically it happened at the same time, and then you just use whatever unbiased algorithm you have for ordering. In our case, it's just a standard hash comparison mechanism. A little bit more on how the groupings happen. I don't know if we need to go into this. For the more technical people, feel free to maybe ask me some questions afterwards. Otherwise, I'll just go through this fairly quickly. I want to be aware of my time schedule. The one thing I do want to mention is on block propagation. I mean, when I showed the demo earlier, you guys saw that it happened very fast. It's about 700 milliseconds for validation. And that has a lot to do with the network graph itself. So So the lines quickly, this is to inform 25% of node, 50% of node, and 75% of nodes. And this is in a 13,000 node network. So the bigger you increase block size, obviously the longer propagation takes. And you can see here for the amount you need to inform the network, it takes longer and longer. So at a 350 kilobyte block size, it takes around 35 to 45 seconds to inform 75% of the network. So you start losing that finality, not losing it, but it starts getting slower and slower and slower. And here's where this concept comes in about concurrent throughput. I hate talking about TPS, but it is technically the correct metric. So let's say I had one node and all transactions always originated from that node. And there was 10,000 other nodes that had to tell about it. So that would be a slow process because it can't leverage the ability it has on gossip or propagation because it's only originating from one node. Versus if it originated from all nodes equally, then each one is adding to the throughput and decreasing the latency. So the reason I mention this is just, you know, even these numbers that people throw around, million TPS, 10 million TPS, 100 million TPS, which by the way is all utter garbage. And please ask me about it in the Q&A so I can really tell you what I think about it. Is that each one of these solutions has a very specific niche for where it fits. And I think that's one of the nice things that Dan also said earlier is a lot of the times people think there's going to be one solution that's going to fit all. And in this space, it's simply not the case. Each one of these constructs is being built for a very specific niche that work in a very specific environment. This is very fast in localized distributed computing where the network graph is somewhere that's concurrent to each participant, but it is not good in a single originating environment where everyone else is simply in the ecosystem to try and leech off of processing power or whatever else it may be. And that's true for most of the solid projects and most of the guys presenting tonight as well. And that leads into something that's closer to a decentralized protocol. So Fantom has this fantastic consensus mechanism, and they're working on a very good VM. But that doesn't necessarily mean that they should be a full blockchain solution. In fact, they're closer to something like consensus as a service or distributed computing as a service. And the reason I say this is because you're gonna have all of these separate but niche specific blockchains eventually. And for them to really facilitate, they need to communicate. Now we hear the word interchain or interoperability or inter blah 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 a lot, and that's maybe on a protocol layer, not necessarily on a infrastructure layer, but it starts becoming important. And I want to hijack this a little bit. I apologize, Dan. In that for this specific example, let's quickly talk about something like distributed custodianship. So if you want to talk about a real DEX, a real decentralized exchange, you need to be the proprietor of your funds. So you need to have your own custodianship and you need high throughput. These are the two systems you're going to have to need, and you're going to need to be able to map assets in some way, but that you can do via smart contracts. So if we look at IDEX today, and we look at if they trade a BTC pair, that's not actually BTC that they're using that's existing on the Bitcoin network. That's a custodian that holds the Bitcoin and then issues wrapped B2C onto the Ethereum network, and then that trades in IDEX. So it seems decentralized because I'm the owner of the wrapped B2C, which technically is an IOTA for the original B2C, but you don't actually have ownership of your funds. And most of the DEXs that are out today all suffer from the same problem. They have some kind of custodian that holds the fund. You hold the IOU, and then that's supposed to be distributed custodianship. So that's an example of something you need with a DEX, but that's not necessarily something Fantom's very good at. Like, that's not where we've done a lot of research. That's not what we've built, and that's not what we're focusing on. You need native on-chain asset matching, and for that, you're going to need a fast consensus layer. That is something that Fantom is very good on, so they can provide that to that ecosystem. And then you need to get to ecosystem agnostic, where all of these chains can work together. But an example of that, and I want to start leveraging this challenge to the community, because I'm getting a little bit annoyed at the amount of technical resources that gets wasted by each project. I mean, how many how many development hours have gone into building block explorers for each one of these chains? How many development hours have gone into building wallets for each of these chains? Versus we could have had one block explorer that facilitates all of them and have the best of the resources working on that. You've got all of these projects that have this very specific niche that they are very good at, that they have strong resources, strong technical development research. It doesn't really matter what it is. And they're leveraging it, but it's it's not being shared. We keep talking about open source and open community and working together, but each one is on their own race to be the first chain that's used by everyone. So we're trying to move towards a space where, you know, Fantom has got this fantastic consensus in VM, and IOTA is fantastic at IoT devices and being able to leverage that in real time in a distributed network without necessarily all of that data going onto a DLT. So, you know, for the smart city projects that Fantom's literally currently involved in, it makes sense to instead use IOTA's tech underneath and leverage that into the ecosystem. Fantom focuses on the stuff it's good at. Once you need, you know, distributed clusters and you need things that don't need a necessary global state, I'd like to grab Holotech and plug that into the ecosystem and have people leverage that. For that same reason, why I mentioned the distributed custodianship is Fusion, who is another project that I work with closely, have got this fantastic distributed key right system that allows distributed custodianship. And Charles and Brett and the guys, thank you for being here tonight. And they're here specifically because they're going to share that tech. And likewise, we're going to share our tech. And we're going to keep doing this until we have this infrastructure layer that actually facilitates all of these chains working together in some way, or ideally something that's an amalgamation of the best parts of all of these chains and actually having a new standard and a new product that's available, leveraging the best parts of each and not having the one focus on what it's good at and then being forced to develop the rest of the components just because they have to. So Charles, I don't actually know if you want to come up or say anything, or if I've pretty much covered most of our conversation, because that's my conversation actually to put a stop in it. Oh yeah. So no, after.
First of all, thank you everyone for being here today and, you know, being here for all these projects. I think what Andre is trying to allude here is you've got so much intellectual capital and just so much capital in general that's going to all these different projects, and folks are trying to solve a lot of different problems. But one of the issues that you're running into is that a lot of these projects, you know, are thinking very much or structured in a way they almost look like this collection of intranets, right? If you think about how all these different protocols are set up, you don't really have interoperability that allows assets to flow freely from one to another. You don't really have this exchange of like information that can flow freely from one protocol to another. And I think the challenge I'd like to throw out to everyone here today and the blockchain community as a whole, and what we've been trying to talk about is there an opportunity, right? Is there today an opportunity for projects to start thinking more holistically, right? Because switching costs are very high. You know, I come from the world of finance, and you know, I used to work for, I helped start a bank consortium, right? Made up of the largest investment banks in the world. And you know, I can tell you that these banks, switching costs are high. For a lot of projects, enterprise projects, switching costs are high, right? So if you're going to go ask a corporation to go out and all of a sudden stake a node and participate in your chain, like you may have some challenges there. But if we can build tech, right, that is easy to use, easy to interchange with, right, exchange information, exchange values with, right, lowers barriers to entry and allows this sort of like, you know, I've heard this term Internet of Values thrown around. How many people have heard Internet of Values thrown around a lot, right? So you hear this term Internet of Values thrown around a lot, but practically it's actually really, really hard to do, right? So if there is an opportunity for folks to coalesce, right, and think about how we can leverage our core competencies in a synergistic way, it starts to become really, really interesting. So, you know, part of what I wanted to just stand up here tonight is not even talk about Fusion, because we're just one small, tiny piece, right? One small cog in this whole thing. But like, how do we start thinking more holistically, right? So that this intranet, this collection of intranet, right? This loosely federated collection of intranets can start to really look like, you know, what this Internet of Values can potentially be. So apologize, I'm not nearly as technical as this gentleman here, but But I wanted to share that point across. So thanks for indulging me. And Andre, thanks for having me up here. I really appreciate it.
But so I just as a closing thought, you know, I want to usher that to everyone. Like Eric Holochain, let's talk. Like Kevin IOTA, you know, let's see where we leverage it over. Let's see what's and let's actually commit to the full ecosystem we can build, and not just our projects. You know, I mean, if we're truly wanting to be decentralized, we should do that on an organizational level as well as a technology level, as well as everything. Thank you everyone for your time.